Hello dear participants of micro irrigation engineering subject. I welcome you to the lecture 17. Lecture 17 deals with water lifting and pumps devices. This is a important topic. It deals with raising water from the source, and this source could be surface water which is flowing in river, through streams, springs, or it is in a reservoir or pond, or it can be groundwater. So, we need to lift this water from the source, bring it to the surface and provide enough pressure so that the water can be distributed at all points of the field. All points of the field, I mean here these points could not be at the same elevation. So, some of these points could be at higher elevation, some points in the field it can be at lower elevation. So, which are at higher elevation, it requires certain energy, it requires certain pressure, so that water can reach there, and particularly in micro irrigation system, it is a pressurized irrigation system. It is in sprinkler irrigation or it is in drip irrigation system, and power means the irrigation is given by providing adequate pressure in the pipeline, and then the emission devices require enough pressure to operate or disseminate water from these points. So, let us discuss some more points related to this topic. So, here we will be discussing on the pump principles which are used for pumping, classification of pumps. We will deal in detail about positive displacement pumps. Now, these pumps means it is working on involving certain parameters. These parameters which are involved in water lifting are atmospheric pressure, positive displacement, centrifugal force, movement of columns of water caused by different specific gravity of liquid, or means mainly it is liquid is basically water. Now, when we come to water lifting devices, so these water lifting devices can be classified. So, this classification can be indigenous water lifts or it can be positive, it could be pumps. So, indigenous devices, water lifting devices, it can operate requiring low head, it requires medium head, or it is taking water from higher head. When it comes to the pumps, so pumps can be classified as a positive displacement pump or variable displacement pump. The positive displacement pump can be reciprocating type or rotary type. So, this reciprocating pumps could be of lift pump or force pump. Single acting, double acting, single force pump can also be single acting or double acting. In today's lecture, we will be talking about a reciprocating pump and a rotary pump. When it comes for the classification under variable displacement pump, these pumps could be centrifugal pump, mixed flow pumps, propeller pump, jet pumps, airlift pump. Now, centrifugal pump could be of volute type, which can be single stage or multi stage. Diffuser pump could be the another category of centrifugal pump, and turbine pumps could be of deep well turbine pump, or it can be submersible pumps. So, as I told you that our main focus will be on the indigenous type as well as in today's class as well as reciprocating type of pumps. So, indigenous water lifting devices, it can be classified further classified as low head water lift, medium head water lift and high head water lift. So, low head, medium head or high head, it could be made on the basis of the height at which water is being taken. So, if it is less than 1.2, we put it under a low head, and between 1.2 to 10 meter it is a medium head, and high head could be greater than 10 meter. Swing basket, Dawn, Archimedean screw, water wheel, these are the other devices. So, swing basket, as you see in this particular figure here, it looks like a basket with this type of things. It is normally made up of mild steel sheet plate, and this basket it is having enough capacity, and then the two ends of this basket is connected with a rope or a string, and so persons on two sides they lift and then bring water at this land surface. So, these are swing basket type of devices are low head water lifting device, and for a small area, for a small plot irrigation, swing basket is used. The Archimedean screw which you see here, this is the another device which is used for low head water lifting device, and here these are the blades. Now, these blades are curved and they are made at a specific angle. So, this angle it is made in when. So, when it is this this spiral shape low angle made these blades, it is bringing water from the water source to the at the field level. So, for low head water lifting device, Archimedean screw type of this particular device is used. If we see the another device, this is also still it is being used for a smaller area, and so you can see here this is a counterpoise type of thing, where and now this device is used where surface water, where the what means it is used where the shallow water exists. So, what this similar kind of the basket or a container which is of a smaller capacity, it is pushed into the water by using the counterweight. So, it is pushed into, and then counterweight what it does, it lifts this particular device and bring this container at the top of the field. So, this is also used for a small area irrigation. Dawn is the another device which is by using the feet, the water is brought from the low head to the field, and then for a smaller area this type of device is used. Chain pump, this is a traditional thing which was being used when the water level, it used to be very close to the ground level, and then this is manually driven. So, there is a drum, and on the drum there is a pulley kind of arrangement where there is a chain, and this chain has got rubber gaskets. So, when we are driving the we are providing the enough driving force. So, that these the water filled the water gasket, it is lifting the water and this is brought at the surface, the water is brought to the surface. So, for a smaller area the water is bringing water at the surface from the well is used a chain pump. Water wheel is another device, it is similar to the chain pump, only thing that the rotation here it is done, there is a the drive mechanism, there is a gear arrangement where the top of this gear there is a beam, and in this beam the means this beam is pulled by pair of bull or a single bull, and then bullock, it is a bullock drawn, and then it gives the circular drive. Then here this drive it makes a linear, and then it comes to the another gear arrangement which gives drive to this wheel, and these wheels have got buckets. So, there are n number of chain buckets, and these chain buckets are when it is being driven. So, it brings water from the source. This source could be again well, shallow deep means shallow depth of well, and then from the water this gets filled in and the water is brought from the well to the field. So, these are the traditional devices which are still being used, where there exists a small or shallow water level exist. Then hydraulic ram. Hydraulic ram, it is a device, it is a special type of pump which utilizes energy of a large quantity of water falling through a small height to lift a small quantity of this water, some part of this water to a greater height. It does not need any external power or external energy to operate. This hydraulic ram is also known as hydram, can thus be employed when some natural source of water like spring or stream is available at some altitude in mainly in the hilly regions. So, lift water from this stream to a higher elevation is brought by using. So, basically hydram it uses the principle of water hammer or inertia developed due to water hammering action in the supply pipeline, and thus in principle it is an impulse type pump. So, momentum of long column of water flowing through a supply pipe is made of force of part of water to a height greater than that of supply source itself. So, where the water source is available, it is brought at the ground level. Now, in order to develop maximum impulse, supply pipeline should be as long as possible. This is important. So, installation of hydram too close to the source of water will not give enough impulse. So, this is important when we are deciding to install hydraulic ram. So, hydram it involves a delivery valve, a waste valve, it involves a valve chamber, pressure gauge, compressed air and non-return. So, basically these are the main components. So, what we see here, there is a supply head, and then from supply head there is a drive pump, drive pipeline, which we can say a delivery pipeline, and then from delivery pipeline water comes to this particular chamber. This chamber has got a waste valve. So, this waste valve operates. So, when it closes, it causes the opening of delivery valve, and now this delivery valve, what happened when it compresses so compressed air it pushes, and then water from this particular chamber it enters to the this pipeline, and this pipeline delivers water at the higher elevation, that is a storage tank. So, this is the arrangement. So, this is the total delivery head, you can see the from this chamber to the storage tank. So, it could be at a very high elevation, and only thing that a small part of the water is being used. So, it does not need, and these are for a specific suitable location where this is possible, such type of device is used. Now, you can see here the operation in this animation, that how the water is. So, water is pushing, and this causes the lifting of waste wall, and that causes the further the delivery wall is opened. So, there is a simultaneous action of closing and opening of delivery, and then part of this water which is going, when this air is compresses, the water is coming out, and then it goes to the storage tank. Now, it comes to the pump. So, pump is a hydraulic machine which converts mechanical energy into hydraulic energy. Hydraulic energy is present in the form of pressure energy. Now, these pumps, when I was classifying, one was positive displacement pump, another one was variable displacement pump. So, positive displacement pumps are also known as constant flow pump. It operates by alternating of filling a cavity and then displacing given volume of liquid. It delivers constant volume of liquid for each cycle against varying pressure or head. So, variable displacement pump, it is just reverse, it has a inverse relationship between discharge and pressure head, means at low head discharge increases, hence power requirement remain high. Positive displacement pump could be a reciprocating type pump which has piston, which is of piston type, plunger type, diaphragm type, or it can be gear pump, gear or lobe or screw or vane type of rotary pumps. So, reciprocating pumps, these are also called piston or displacement pumps. They function by means of piston movement which displaces water in cylinder. Flow is controlled by valves. A piston or plunger is a cylindrical piece which moves backward and forward inside a hollow cylinder. The capacity of reciprocating pump, it depends on size of the cylinder chamber, means how much is the diameter and what is the length, and of course, what is the speed of stroke. So, means there are three things involved. One is size of the chamber, size it means it is the diameter of the chamber, second one is the length, and then next the other important thing is at what speed this strokes it makes. So, here one of the example which we normally see is hand pump. Hand pump is the one of the category, it falls under the reciprocating pump. Now, a reciprocating pump or hand pump, it operates by using, you can see here there is a crank, and this crank is connected with the connecting rod, and this is the cylinder. So, length of the cylinder and then the diameter of cylinder, and then there is a piston. So, piston it moves forward and backward. So, when it is going backward it creates suction, and when it is going forward it creates enough it is pressing the liquid which comes out of the delivery pipeline. So, this total head developed will depend upon the at what depth the water is being taken from the source. So, this is the way it works. So, this is a typical hand operated reciprocating pump, where there is a you can see here there is a water level, and then the there is a suction pipeline, and then suction pipeline, at the top of the suction pipe there is a check valve, and then this part is a cylinder, where in the cylinder there is a piston, and then piston it has got a check valve. So, water enters through the check valve, and then finally, when so there is a suction as well as delivery, the means forward and backward motion, it causes the water to get inside the cylinder, and then it when it is a pushing out, then the water comes out of the cylinder. So, this is the arrangement, it is the rotary pump. This is a common rotary pumps, commonly it is used in pumping lubricating oils. It is also used as a booster in irrigation pumping. It has a driving gear which is rotated by an outside source. What you are seeing here, the water is coming from this end, and then this is a driving gear. This gives drive to this driving gear, and then driving gear it gets it gives movement to the idler gear that is driven by driving gear. So, their movement creates a partial vacuum, and this brings in a replacement of supply of water along inlet side. You can see here how the rotary pump in this animation, this is there. So, water is coming, it is giving the drive, and then how the water is being pushed outside. So, it could be for water or any other liquid which is heavier than wet liquid. So, it can be the rotary pump. Now, shallow well reciprocating pump, for as the name it says shallow well. So, means they are operating at low head, where the water is available at low depth. So, reciprocating pumps for shallow wells are usually of the lift type, using atmospheric pressure to raise water in the pump column. The piston, when moved up and down by the movement of handle, that displaces air from the pump column. This movement causes the creation of vacuum, which permits forces of atmospheric pressure to push water from well up into pump column and from it to the outside. Deep well reciprocating pump, by introducing pump cylinder with its plunger and valve into the water in a well. So, water can be lifted to almost any desired height. It may be manually up to 45 meter or mechanically operated. So, when I say mechanically operated means it could be given a drive by engine or motor. Operated reciprocating pump usually employ a crankshaft arrangement placed at the top of the well to change the rotating motion of the power to that reciprocating motion of the piston. So, means the speed will be created depending on the requirement. Now, type of reciprocating pump can be made based on the construction and how it operates. So, we say that based on construction and operation. So, reciprocating pump, it can be single acting pump. Single acting pumps have one discharge stroke for every 2 strokes of the piston. Water is delivered during alternate strokes of piston. So, during delivery strokes of the piston, air in the vessel is compressed to a greater pressure than corresponding to the head of water at the bottom of the delivery pipe. During suction stroke, the pressure of the air in the vessel, it maintains flow of water through the delivery pipe, thereby ensuring nearly continuous discharge. So, this can be explained by using this particular figure. Here we can see the you can see here there is a sump, and then water is being taken from the sump by installing a suction pipeline, and in the suction pipeline you see there is a arrangement, there is a cylinder, there is a piston, and then piston is driven up and down. So, when it is being it is operating, so it creates, when it is the air is being pushed, compressed. So, then delivery valve opens and then it supplies water. So, it is similar to the reciprocating pump, which I have already explained you. You can see here how the single acting, the reciprocating pump, it operates by this animation. You can see here how the valves it opens and closes. Double acting pumps, they are constructed with piston and valve, which are arranged such that water is pumped on both the inward and outward movements of piston. There could be duplex or triplex type pumps. Now, duplex and triplex pumps consist of 2 or 3 pistons respectively, and are designed to pump a continuous stream of water with the minimum pulsation, often against high pressure. Now, we can see here double acting reciprocating pump. So, you can see here these are the 2 delivery valves. Now, when water is being pushed, means pump is being brought back. So, this valve is closed and this valve is kept open, and when we are means the suction, means what happened when we are pushing the cylinder in this direction, then this valve gets closed, this is your suction of water takes place, and then it pushes the water and then delivery of water. So, this valve will be closed and this valve opens. So, this is a double acting reciprocating pump, and this can be seen this animation this animation you can see a diaphragm type of reciprocating pump, where the water is how these valves are opening and pushing in the respective directions. So, this is another kind of a reciprocating pump. These are very commonly used devices which are used for low water lift. So, we have discussed on these topics, and then you can refer in detail in these 2 books, and also enough literature is available in internet. Let me summarize this lecture. We discussed about different types of water lifting devices. We also discussed about principle of operation of reciprocating type of pumps. We discussed about positive displacement pumps, single acting, double acting, rotary pumps. Now, in forthcoming lecture, we will discuss about variable displacement pump. Thank you very much.